Bismillahirrahmanirrahim. Okay students, today we are going to discuss equilibrium constant and its unit, means how to derive its unit by knowing the equilibrium constant value. First of all, what is equilibrium constant? We have already studied that equilibrium constant is the ratio of product of the concentration of the products to the product of concentration of the reactant at equilibrium state. So a quick review of this definition, that it is a ratio of the multiplication of the products. Products means the thing that is written on the left hand side of the equation, to the product of the concentration, means multiplication of the concentration of the reactants. Reactant, what is reactant? The thing that is written on the right side of the chemical equation. Mathematically, this term can be written as Kc is equal to product of concentration of the products over product of the concentration of the reactants. For a reversible reaction, the reaction and the product sides is written as for a reversible reaction, the product side is written in the form of numerator, as you can see in this mathematical form. On the numerator side we have written the product, and the reactant side as denominator. See, the reactants are written in the denominator form, and the coefficient for each is raised to the power of that substance from balanced chemical equation. We have discussed that also in very detail in our previous lectures, that for example we are having a chemical reaction, that is H2 plus O2 in a reversible reactions to form H2O. This term, the number, this coefficient which is used to balance the equation, is used as in the form of power in the Kc expression. So here the point is referring towards this statement, that n, the coefficient of each, means this is one coefficient, this is the second coefficient. Unfortunately there is no coefficient over here. So the coefficient of each is raised to the power of that substance, means whenever this substance is written, that is H2 is written, whenever we write the H2, the 2 is written in the form of power. So, and the coefficient of each raised to the power of that substance from balanced chemical equation. Now let's move ahead, that how to derive the unit for Kc of a particular equation. Just imagine a chemical reaction, that is hydrogen and iodine reacts together to form hydrogen iodide. First of all, we have to balance the chemical equation, that on the right side there are two hydrogen atoms and two iodine atoms, means hydrogen molecule and iodine molecule. Reversible reaction to form the hydrogen iodide. So in order to balance, we are going to write 2 with hydrogen iodide. Now the Kc expression, we know that in Kc the left hand side, that is the product side, is written in the numerator, and the right hand side, that is the reactant side, is written in the denominator form. So Kc is equal to hydrogen iodide raised to the power of the coefficient over concentration of hydrogen molecule and the concentration of iodine molecule. We know that the unit for concentration is mole per dm cube, mole per decimeter cube. By replacing all these terms with mole per decimeter cube, we will be able to calculate the unit for the reaction. See, Kc is equal to mole per decimeter cube square, as there is a square term in the hydrogen iodide, over mole per decimeter cube for hydrogen and mole per decimeter cube for iodine. So all these terms cancel out each other, and the remaining term remains nothing. So there is no unit for this chemical reaction. Let's move towards the second example. Example number 2. N2O4 decomposes into nitrogen dioxide in a reversible reaction. First of all, the Kc expression for this equation, Kc is equal to NO2 concentration, the coefficient in the power NO2 square divided by N2O4 concentration. So in order to derive the unit, we are going to replace these symbols with the mole per decimeter cube term, their unit. So unit of Kc is equal to mole per decimeter cube square from the expression over mole per decimeter cube. There is no power here, so we are not writing anything. So the square will be cancelled out with the denominator. What is left behind? That is mole per decimeter cube is left behind. So unit for this particular reaction, whenever you write the Kc value for this particular reaction, you are supposed to write this unit with that. ठीक है ना? Okay. Example number 3. See, there is another example, that is the formation of ammonia, NH3. How ammonia is formed? Nitrogen reacts with hydrogen to form NH3. 1 mole of nitrogen reacts with 3 mole of hydrogen to form the 2 moles of ammonia gas. So the Kc expression for this reaction is that Kc is equal to ammonia square, nitrogen with no power and hydrogen with cube. Now replacing all these terms with the unit mole per decimeter cube. So unit of Kc will be mole per decimeter cube square over mole per decimeter cube into mole per decimeter cube. Now just simplifying the term, the square will be cancelled out, means this whole term will be cancelled out with this square, leaving 1 power behind, and this 1 power multiplied with this 1 power becomes 1 over mole per decimeter cube square. So the unit for this particular reaction will be mole inverse square into decimeter to the power 6. So whenever you are going to write the Kc value for this ammonia reaction, that is Kc, let's suppose the value is 1, 2, 3 mole inverse square decimeter cube 6. In this way you are going to write the value of this equation. Thank you boys. Allah Hafiz.